Welcome to Physics World Online College, where we simplify physics for everyone to learn, understand, and apply in every area of life. In our class of today, we'll be considering case 2 for motion under gravity, that is, for the downward motion, vertically downward motion. When a body is released from rest at the top of a cliff, mountain, or building, or for a body that is suspended at a height like the mango fruit, is already at a height, and then it falls from that height to the ground. That is what we are considering today. It's a follow-up of our last class where we discussed when the object is thrown upward vertically. So in our class of today, we'll obtain the half formulae for downward motion. We remember the key statement will be at the maximum height, the initial velocity of the body is 0. We'll obtain the formula for obtaining that maximum height if we are asked. We'll obtain the half formula to calculate the time it takes to from the height fall to the ground. Then from which we will get the total time of flight. That is, if you are given the downward motion, you can also use it to get the time it takes to from the ground gets to the top. So you add the two times to give you the total time taken, capital T. Then we'll obtain the range or horizontal distance, and then the maximum final velocity, also called the velocity before hitting the ground. I will explain when we get there. So let's take it this way. We recall that for a body or object released from a height or we put it this way, a body released from rest at a height or top of a tower, cliff, building, mountain, etc. Now, the issue here, once you read the body is released from rest or is released from a height, this you will just bring your mind to the word downward motion. It means the object is already at the top and then it falls to the ground. So that takes the downward motion into effect. Let me put it in a hypothetical diagram. So we say this is the height of the tower. The object falls from rest to the ground. Now, as the body is falling from this rest, at this maximum height, at H max, at maximum height, at H max, the initial velocity is 0 at the maximum height. Here, this is the horizontal component of the velocity. This horizontal component of velocity is not 0. So I want you to take note. This velocity that is 0 at the maximum height is actually the initial vertical component of the velocity. Like I said, in a subsequent class, I will explain again about horizontal motion, where I will tear into two this velocity we are using here, and we are saying is 0 at the maximum. I will expatiate on it in that class. So for this class, just permit me to say that at the maximum height, the initial velocity is what? Is 0. So as the body begins to fall down, its velocity will be increasing. because it is falling in line with gravity, and A here is plus g. So its velocity increases with what? With time. Which velocity? Actually, it is the vertical component of the velocity that is influenced by gravity, not this horizontal component. It is not dependent on gravity. Good. So this vertical component of velocity will increase with gravity and becomes maximum before the object hits the ground. And this maximum velocity will give it gt or gt2, which we can also obtain as square root of 2gh. We'll get it. So if we liken to the previous example in the last class, where we throw the object up with 80 meter per second velocity, now once the body is coming down, this velocity is 0 here. It will increase from 0, 10, 20, 30, and becomes what? 80 maximum before it hits the ground. Once it hits the ground and comes to rest, that final velocity becomes 0. Good and fine. So we want to obtain this maximum height. We'll get the formula. If we're asked to look for it, h max, we'll get the time it takes to get to the ground, t2, or we call it t down. We'll get the maximum time, that's total time, capital T, which is 2t2, and then we'll get the horizontal distance, which we call range, or they will say the distance from the base of the building or cliff to the point where the body hits the ground. Again, so that gives you the what? The range. So let's obtain the half equations. Thus, now we say to obtain the maximum height of the body, h max, we use the second equation of motion under gravity. What is that second equation? H is equals to ut. I use plus. Why am I using plus? The body is going what? Down. Plus half gt squared. So I will apply my statement, which says, but at h max, at maximum height, the initial velocity is what? Is 0. So this initial velocity will be what? 0. Therefore, I have that h is equals to 0 plus half gt squared, which means h is half gt squared. This gives us the formula for finding the maximum height. If you are asked, the maximum height is what? Half gt squared. Let me call this equation E. I stop at equation D or D prime in the last class. So this is equation E for the maximum height for the downward motion. From here, we can get the what? Time it takes to get down. That's T2. So we say to obtain the time taken for the body to fall to the ground, for the body to fall to the ground or reach the ground, small t, we use this formula. Small t, we use equation E. In order not to repeat ourselves, we use equation E. So from equation E, we have h is half gt squared. I cross multiply. These two will multiply h. So I have 2h is gt squared. I divide both sides by g. So I have that what? 2h over g is equals to t squared. So for me to get t, I will take square root. So let me write it this way. Say or t squared is equals to 2h over g. Therefore, I will take square root to obtain what? The time, small t. So therefore, t is square root of 2h over what? Over g. And this formula we use to get what? The time it takes for the object to fall down. So we say that is t2 or t down is square root of 2h over g. Call this equation f. There's a point to note here. This equation f tells us that the time for the body to fall down is independent of what? Of the mass. That is why that experiment I told you about Galileo, that he went to the top of the mountain and released two objects and both reached the ground at the same time, because they both are falling with the same gravity from the same height. H and G are the same. So irrespective of the mass, the T to reach ground will be the same. So this formula tells us that time is independent of what? Of masses. Of mass or masses. So the time it will take a body to fall down is independent of its what? Of its mass. That's what this equation verifies or proves. Now, we will now from this time to get down, we will get the maximum time or total time. So we say to obtain the total time taken, which I also called time of flight or total time of flight, that is capital T. We use equation F. So what does equation F says? Equation F says that T2 is what? 2h, square root of 2h over g. So with that, we will have that T, capital T is 2t, and capital T is 2t2, time to what? Get down. So that gives us T equals 2 times square root of 2h over what? Over g. So you multiply it by 2. Let's call it equation G. So this gives us the total time taken for the body to both go up and also what? Fall to the ground. The next thing that we need to obtain is the range. For us to get the range or horizontal distance, to obtain the horizontal distance, or range, like I said, which is the distance from the foot of the cliff or building to the point of projection where the body hits the ground, we use the second equation of motion. We use the second equation of motion, which says h is equals to ut. I use plus because the body is coming down, half gt squared. Once again, I will come to that my explanation about horizontal motion, which I said I will elaborate in a subsequent class. Now, we say the horizontal distance is not affected by gravity. For the horizontal distance, this velocity, the horizontal component of the initial velocity, is constant. And since it is constant, the value of g is 0. So we will say, but at constant horizontal velocity, constant initial horizontal velocity will be better. Initial horizontal velocity u, the acceleration due to gravity is 0. That is, as u is constant, or us is constant, g is what? Is 0. That is, at constant u, comma, a equals g equals 0 for the horizontal motion. So if we apply it into this equation, we will have that h becomes what? Arrow. H becomes arrow. So we have r equals ut. This u here, like I said, is this horizontal velocity, which is not 0, times t. This t is what? T2. That's the time it takes to get down. So we can obtain our range to be, I can have it two way, u times t. T is what? U times square root of 2h over g. I can call this equation h. Then I can use this as well, okay, which is ux square root of 2h over g. Why am I using subscript s? I will explain in subsequent class. So let me call this h prime. So h prime and d prime from the previous class needs further explanation. So this velocity here is not 0. In the case for horizontal motion, it will be given to you. It is not 0. What is actually 0 is the initial vertical velocity. That is what? That is 0 at the maximum height. So we'll get to learn more about that subsequently. Now, lastly, let's get the maximum height, the maximum velocity, v, before it hits the ground. This maximum velocity is the maximum vertical velocity, the maximum final velocity of the vertical motion that is influenced by what? By gravity. That is what is v max. So to obtain the maximum velocity or velocity of the body before it hits the ground, we will use either of the first equation of motion or the third equation of motion. We will still obtain the same what? Answer. So we use the first equation of motion, which says what? V is equals to u plus gt. And our assumption will O, because we are considering the vertical component of velocity or of the motion. But u equals 0 at what? At maximum height. So this means v is equals to 0 plus gt, which means v is equals to what? Gt. This t, like I said, is what? Is T2. So I can say v max is gt2. V max equals gt2, the time it takes to get down. H, let's call this equation I. So we can use this to get the maximum velocity before the body hits the ground. Or we say from the third equation of motion, from the third equation of motion, of course, you know I'm referring to motion under gravity now. We have that we have that v square is equals to u square plus the motion is coming down 2g-ish. And then this assumption will stand, but at maximum height, at h max, initial velocity u is what? Is 0. So I apply it, we have v square is equals to 0 square is 0, 2 plus 2g-ish, which means v square is equal to 2g-ish. So we have that v square is equals to 2g-ish. I will take square root, which means v is the square root of 2g-h. So I can say that is v max is square root of what? 2g-h. Let me call it it's the equation I. So because both of them is used to obtain the v max. So I'm just saying therefore. Let me say therefore. Or in conclusion, v max, maximum velocity in the ground, is either you use GT2 or square root of 2g-ish. So both of them will give you the same answer, which is what this question is asking for. So if you know v max, you can use it to get h. You make h the subject of formula. Good and fine. So let's solve the question that we have before us. That's example 2. Then thereafter you will do the assignment. Let's take solution to example 2. Solution to example 2. This is example 2 because I solved example 1 for upward motion in the last class. So we are given that a ball is released from a height that says it's already at the top, or a mango fruit drops to the ground from the top. It's already at the top, so it's at rest and forced to the ground. So you cannot use vertically upward motion here. You will be wrong because this object is at the top and forced to the ground. So take note of that. So I can sketch. We're given the height, so we're given h. We're given h as 20 meter. We're given g as 10 meter per second square to find the values of those other quantities. So let me sketch hypothetical diagram. So we have the height, which is given to us already, h 20 meter. That's the height. Then the object force from rest to the ground. So that's the horizontal component of velocity, not given here, but we're given, since it's falling from rest, the initial component of the velocity, the initial vertical component of the velocity is 0 at this h, at h max. U is 0. Then the object is falling down. Then they want us to what? Get the things we need to do. This is plus g, which is what? 10 meter per second square. So now let's find the things they want us to get. Once again, the first option here asks us to find the velocity after time 1.2 seconds. That velocity is to show that the velocity is increasing as the body is falling down under what? The influence of gravity. The velocity of the body is in line with gravity, so it's increasing with time. So they want us to get that velocity to show that it increases. Here, that velocity is 0, but at time t, that's option A, velocity after 1.2 seconds means t is 1.2 seconds. We should find v. So for the vertical motion, the initial velocity is 0 at the maximum height. And of course, g is given. G is 10 meter per second square. So let's find that velocity. So we use the first equation. From first equation of motion under gravity, we have that V is equals to U plus GT. Nobody will ask, why am I using plus? The body is falling down in line with gravity. So I have V is equals to U is 0, G is 10, T is 1.2. That gives me V is equals to 0 plus what? 12. 0 plus 12 is what? 12. So the velocity is 12 meters per second. Started from 0. It has increased to what? 12 meters per second. It's not here maximum, because we will get the maximum velocity in the last question. So you will see it has increased from 12 to the value we will obtain for the maximum velocity. This just shows that the velocity is increasing and is falling in line with gravity. That's what this question shows. Option B says, find the time it takes to fall to the ground. That's small t. Time it takes to fall to the ground, small t, which is T2. We just quote from the formula, from T2 equals square root of 2h over what? G. Well, I know the h is 20, so we have square root of 2 times 20. G is 10 over 10. That gives us T2 is equals to square root of 40 over 10, which gives us square root of what? 4. 0 we cancel 0. And square root of 4 is what? 2 seconds. So you see, at time 2 seconds, the body will what? Will reach the ground, and its velocity will be maximum at that time. That is why at 1.2, it is not yet maximum, but it is increasing. So let's see the total time taken. So see the total time, or time of flight. Total time taken, I told you that is capital T, is giving us what? 2t, which is 2t2 or 2t down, and it's giving us 2 square root of what? 2h over g. That means we're saying t is 2. 2 times 4. 2 times 20 over 10. That gives you 2 times square root of 40 over 10, which is 2 times square root of 4, which is 2 times 2, giving you what? 4 seconds. Once again, it confirms that it takes 2 seconds to fall to the ground, and it will take 2 seconds to get to the top. 2 plus 2 giving us what? 4. Which, since we have obtained this time before, I could have just used 2t2, 2 times 2, and obtain what? 4. It is acceptable as well. So let me just put it down. Or t is equals to what? 2t2. 2 times 2 giving us what? 4 seconds. Lastly, we look at the maximum velocity. The maximum velocity before hitting the ground. And I've said, this velocity before hitting the ground, is very important. To obtain it, that's option D. The velocity before hitting the ground, or Vmax, is given by, let me use GT2. That will give us, G is 10, T2 is what? 2, giving us what? 20 meters per second. So 12 after 1.2 seconds. At 2 seconds, it will be what? 20. So Vmax here is 20 meters per second. Or you can also obtain it from that other half equation, that is square root of 2gh. This will give us 2 times 10 times 20. If you do that, that gives you 400. Square root of 400 will give you what? 20 meters per second. Good. Confirming that the two formula gives you the same answer. Now, I want to say something just to help address that question once the body penetrates into the ground. Now, if the object falls and it comes to rest, I said the velocity is maximum before it hits the ground and comes to rest. If it comes to rest after hitting the ground, the final velocity becomes 0. However, if we assume that the ground is soft, maybe it's sandy, and then the object is sharp, maybe like a bullet, and it pierces into the ground, it's able to penetrate into the ground, what will be the thinking? Two things you can be asked to find there. It's either they ask you to find the retardation as the body forces itself into the ground, or they ask you to find the distance or the height it will penetrate the ground. So how will you obtain that? I will just explain it in this concept of class so that that question can be answered. In that case, where the body penetrates the ground, this maximum velocity will become the initial velocity at the start of that penetration. So V max will be what? U, initial velocity when the body starts penetrating. So that value will be what? 20 meters per second. As it penetrates the ground, it will finally stop. It will finally come to rest inside the ground. So in that case, the V there is what? Is 0, because the body what? Comes to rest. The body comes to rest. So if that is the case, you can get what? You can get the retardation if you know the penetration, that's the distance. So if the distance of penetration x is given as h, is given any value they give you, maybe 10 meters, you can calculate A, the retardation. So you will use this formula from the third equation. If you have V square is equals to U square plus 2GH. V is 0. This is 0. U is 20. U square plus 2 times 10 times 10. So we're looking for, okay, we're looking for A, that's the retardation. Let me not use H. So we are looking for, let me use this rather, because it translates into linear motion, 2AX. Good. So we have V is 0 square, U is 20 square plus 2 A times 10, which is this. This gives us 0, 400 plus 20A. So you collect like terms, you will have, if you collect like terms, you will have that minus 20A is equals to 400. That gives you A is equals to 400 divided by what? Minus 20. This gives you what? Minus 20 meter per second square. It is minus telling you it is what? Retardation. So therefore, the retardation minus A will be equals to what? 20 meter per second square. That is how you answer question where the object penetrates the ground. So the interpretation is in this point. For the motion under gravity, it is maximum before it hits the ground. Once it penetrates into the ground, that's linear motion, rectilinear motion, uniformly accelerated motion. That maximum velocity becomes the initial velocity at the point of entry. So you have to take note of that. Then there's another question where they give you the retardation, they ask you to find the distance of penetration. So is to now make x the subject of a formula in that case, and then you find x. I believe with this, that question can be answered because somebody asked it and I promised to address it in the course of the class. I've done just that. So please attempt this assignment. After you have solved it, post your answer on the comment section. I will respond appropriately. Thanks for your time. Bye-bye.